All right, there we go. All right. So do you guys need more time to play with it? If I was to ask you to make a conjecture, can you guys, do you see when you are able to make a triangle and when you cannot make a triangle on here? So let me ask you this. If you guys take a second and look at my screen just for a minute or two, can I make a triangle right here? Why not? The sides are too short, right? They're never going to connect. What if I do this? Will I be able to make a triangle with those two sides? You can, right? So can somebody make what has to be true in order for you to be able to connect? What has to be true with the measurements of the sides? Sweet. So somebody at home, you guys can see it. She's saying the sum of the two shorter sides have to be greater than the longer side. So I don't know if you actually saw that mentally and you broke it down like that, but I know you can see it physically, but the green and the blue have to be greater. Their sum has to be greater than the third side, or it's just not going to reach. What if I do this? Anybody try this? I want to know, what about when they're the same? 6 plus 6 is what? 12. Do you guys think it's going to make a triangle? Yes or no? No, right? Because if you think about it, the only time it's going to connect is, can't do it because I'm old. I don't got steady hands. Although I did golf really good this weekend. When you do that, and so it doesn't make a triangle, right? So if it's equal to or less than their sum, it will never make a triangle. Does that make sense? Okay. So let's go ahead back to the pair deck. No more fun time. So this is what we're going to go over a bunch of theorems that have to do with less than, greater than kind of deals, kind of things. But basically, an easy way to remember the theorem is that the two smaller sides always have to be greater than the third largest side. Okay. So I want you to go through this right quick and do the three sides form a triangle. If you want to circle the ones, make it faster, whatever is easier for you, I don't really care. So just kind of go through those. I think you can drag those in there. You can I think you can move those. Oops. You can move those in there and stuff. So let's kind of go through some of these right here. Let's do, for example, the 2, 4, 7. Does that make a triangle? No, right? What about the 7, 7, 7? That one does make a triangle. What about the 5, 6, 12? Does that make a triangle? No, right? What about the 6, 6, 12? Does that make a triangle? No. So do y'all get how that works and stuff? Okay. So that's just kind of be looking for that. That's how you can kind of tell if it does make a triangle. When you look at the theorem, this is the theorem itself. You don't have to do all three of these. Basically, any two sides have to be greater than the third side. But really, the only test you have to do is the one that we just did. If the two smaller sides are greater than the third, so that's the only one that matters. So the two smaller sides are greater than the third side, you're good to go, okay? So we're gonna do one more link. I think we're gonna do a few actually. So I want you to click on this one now. Okay. Now this one here says you have to do this on a piece of paper. There's some questions underneath it. You don't have to do that, but if you can kind of just read those and see what the point of this investigation is. Do you guys at home need the link? I don't know if you do. Let me see. Send you the link. Okay. So I sent you the link for the new one. So play with this triangle right here, and I want you to notice what is the correlation between the side and the opposite angle. So you'll notice that the green side correlates with the opposite angle, which is green. So the colors together is the side and the opposite angle. So I want you to look at the largest angle and then look at the largest side. What do you guys notice about the size of the angles and the measurements of the sides? What conjectures can you guys make? And that's what I want you guys to focus on. Yeah, sometimes it's really slow. I know I was trying it this morning. I'll give you guys some time to kind of play with it. But again, what do you notice about the size of the angles related to the sides size? If that makes any sense. Yeah. So as you're kind of looking at this right here, what do you guys notice about the largest angle relative to the sides of the triangle? Do you guys notice anything? Let me ask you this, which is your largest angle? Yours is the same, right? Is it the green, blue, or the red? Is it green, right? And you'll notice, which is your largest side? The green, right? So you guys notice that the largest angle is opposite your largest side. Your medium or your second largest angle is opposite your second largest side. And then your smallest angle will always be opposite the smallest side. Does that make sense? Okay. So that's kind of what, this next theorem that we're going to talk about. And here, let me just take you to it. Well, actually, don't state it, but the theorem just states basically that the size of the angles determines the measurement of the sides that it's opposite to, right? So the largest side of a triangle is opposite the largest angle, et cetera, et cetera. So you can identify those. If you know the measurements of, and this goes back and forth too, if you know the sides, then you'll know what angles are the largest, or are their sizes relative to each other, right? And so there are some theorems where, so this is basically what we just kind of saw. If this theorem here states that if the measurement of angle A is larger than the measurement of angle B, that means that the sides that they're opposite to are going to have that same correlation. So BC would be greater than AC. Since angle A is opposite BC, that has to be greater than AC because of their angle sizes, right? And then the converse, if you know their sides, then you can do a less than, greater than, based on the sides. You can do that, a statement for the angles as well. Okay. I forgot about this one. The measure of an exterior angle of a triangle is greater than the measure of each of its remote. Well, yeah, that makes sense because we've done this theorem before where the sum of angle 2 and angle 3, if you add those, has to equal the measurement of angle 1. So that one, pretty straightforward. So what I want you guys to do is, you'll have, I believe this is on your test if I remember correctly. You have something simple like this, write the angles from largest to small. It might be a little bit harder than this, but I want you to list the angles from largest to smallest. All right, so let's do a couple of these. I'm going to call on you. I will start in person. Then I'm gonna go to those of you at Zoom. So those of you at home, please be ready as I'm gonna just randomly call on you. So be ready to answer, please. So, Miss Allison, what'd you get for the first one? Yes, she did that fast, but she's right. Y'all get that? So E, D, F, right? E, D, F. Okay. So let's see. And so far as this, guys, is this pretty easy so far? What do you guys think? It's not too bad, right? Let's just check one more. What should we do? Let's do Miss Flores. Sorry, that kitty was just jumping out at me. Okay, Miss Flores, do the same for B. largest to smallest. So she said QRP. You guys agree, disagree? Yes, agree, move on. Yes, so angle Q would be the largest. Somebody's coming in with QPR. QPR. Yeah, I would think on this one, so if I go, so I see the largest side is 8, so the opposite angle is Q. Usually when in class, I would draw a line from 8 to Q. So Q is the largest angle. The second largest side, or the median, would be 6, so the opposite angle would be P. So then I do think it's what, QPR, right? Is everybody okay with that? QPR? Let's do one more. Let's do one more. So Mr. Caperton? So CAB, what do you guys think? Yes? Nice, love it. So CAB, CAB, I think we, no disagreements there. I think we love it. We like, and sometimes it can get a little confusing, right, with the lines and stuff like that. It's kind of a pair deck. I don't know if you can draw lines to it and stuff. But anyway, okay. So let's move on. Now this one right here, you're gonna go the other way. This time you're going to go from, you're gonna use the angles to determine the sides, all right? You guys know how to find that third angle? Yeah, okay, if you don't, let me know. So do the same thing. I want you to list, so we'll do a couple, okay? So I want you to list the sides from largest to smallest. Largest to smallest. Remember, when you're naming a side, use 2 letters. Okay, use 2 letters. Also, never, when you're doing these kind of problems, these might be to scale. Never go by the pictures being to scale. You go by the angles, the numbers. I think on the test, purposely, we're going to give you like a triangle that looks equilateral, but we're going to make the numbers all different and stuff like that. So never, ever go by the way it looks, ever. You guys need more time? Anybody need more time? Okay. Sure. If you go up here, can you see it? Yeah. Okay, so I'm gonna go to you guys at home. Carissa, what did you get for A? Largest to smallest?
I got DF, DE, and EF.
That is absolutely correct. That's right. Okay, that was right. Okay, so good job. Let's see, Mr. Davy, what'd you get for B? Mr. Davy, Christian, B. Mhm. We don't want the angles, we want the sides. So like, if you look here, did you find this angle right here? Okay, so you have to add those, subtract from 180. So this gives you 105, I mean 75, right? So you want to find those sides. I'm going to come back to you, okay? So I need you to find what those least to greatest, okay? We're going to come back to you. Mr. Day, can you do C?
For C, I have SV, TV, and ST.
Yay, nay, thumbs up. All right, guys, looks like in-person agrees with you, Mr. Day. I'm going to believe my in-person. They seem pretty sharp. But yes, nice. Mr. David, are you ready? So this angle is 75, right? So you go to the opposite side, which would be here, right? So the largest side would be PQ. And that's what I got, right? I know, correct me if I'm wrong, guys. And then your second angle would be here. So then this right here would be, the second one would be PR, and then the smallest would be RQ on that one, okay? Make sure we're paying attention, Mr. David. All right, so let's continue. So those are the answers. I would think this is not too bad. You're just kind of using inequalities to do that as you're kind of going through there. Take a second, answer this question. This is more maybe what you might expect to see on the test, right? See if you can figure this one out. Which two streets form the largest angle? So on this one, I just ask everybody, which two streets make the largest angle? Yes, ma'am. Good job. That's right. Excellent. So MLK Boulevard and Valley Road, right? Those make the largest angle because 175 is the largest length, et cetera, and then you kind of go from there. Excellent. Good job. You guys are killing it. So on this one here, let me just ask a question real quick. Can we make a triangle with those sides? Yay or nay? No, right? Because if you do 2 plus 3 gives you 6, it's less than the larger side, so it's not going to connect, right? So no bueno, no good. This one here, go ahead and answer that right quick. Get a little bit of practice before we do the next activity. So, Ms. Guzman, what do you think? Can this make a triangle? Yay or nay?
No.
That is absolutely, I don't know, let me see. So you said no, what do you guys think? Yay, nay? Agree, disagree? No, what do you mean by you say no? You say no, I don't agree, or no, I don't? You think it can? Okay. So on this one here, remember, you want to always choose, the easy way to do it, just pick the two sides, right? The two smallest sides, which would be 12 and 7. You're going to add those. You're going to do 12 plus 7. See, this one did all, oh wait, this is the next one, isn't it? Oops, you do 12 plus 7, and that gives you 19. That's greater than 13. Therefore, it does, right? It works. What the? This is wrong. Here's another one. You do the same thing with decimals. You know, you just put those, you know, you pick the two smallest sides, add them up. You don't have to do all three of these, right? You just have to do the two smallest, add them up. That's it, right? Why waste your time? We don't got time for that. We're gonna skip this. This is not on your test. And it's not on your homework. Okay. Hey, why is this showing it like that? All right. So kind of ignore this right here. I feel like a slide got deleted or something. It wasn't like this morning. Maybe I deleted it by accident. Oops. But what I want you to do, now that you know what you know about triangles, what makes a triangle, what doesn't make a triangle, I want you to try to think of a range between two numbers, right? You see that question mark? What can be the smallest number that we can use to make it work, or the smallest number that doesn't work, and maybe the biggest number that doesn't work, if that makes any sense. So you want to think of a range, right? So think of numbers that do work. Let me just give you an idea here. Would 4 work? So 4 would work, right? So try to think of numbers that don't work and numbers that do work. And can you think of a range? Okay, so these numbers work between these two numbers or something like that. See if you can get an idea of what numbers work, what numbers don't work. And then we're going to talk about trying to figure out, well, what's an easy way to figure out what number, you know, how can we figure that out quickly? So try to figure out numbers that do or do not work. I think the question that I'm asking is, what's the smallest number that doesn't work? What's the biggest number that, the first big number that doesn't work, excuse me. Wait, that may not make any sense. I don't think that makes any sense. There are two numbers. Let me ask you guys this. Do numbers smaller than 3 work? Yes or no? That's kind of a weird question to ask because I know you guys are really smart. Maybe thinking, well, it depends what you're asking, Mr. Lopez. Let me ask you this. Does 2.5 work? Let's see, if the question mark was 2.5, the two smallest sides would be 3 and 2.5. So if I do 3 plus 2.5, is that bigger than 5? It is, so that would work. 2.5 works. What about 2.2? Does that work? Jacob, you're really close. Jacob said that the range is going to be between 2 and 5. And I think he nailed the left boundary. The smallest number that doesn't work is 2. Wait, that doesn't make sense. That's the first smallest. Whatever, mister. Okay, I just stopped. But 2 doesn't work. However, 2.00000001 does work. But 2 doesn't work because 2 plus 3 gives you 5. Okay. So that's kind of the way I see that. That's like kind of like my left bound. But so 2 is one number that doesn't work, right? Why do I got to do attendance? Anybody figure out the next number? So let me show you what, Jacob, I'm going to show your answer if you don't mind. So you'll notice Jacob, this is what I'm looking for. 2 to 5. His range is 2 to 5. 2 doesn't work. I want that number. Anybody figure out? It's not 5. Oh, those of you at home can't see. He has basically 2 to 5, although his inequalities are backwards, but that's okay. I'm not looking for 5. Yeah. Okay, so let's try 7. So if I put 7 here, would 7 work? Would 7 make a triangle? It does, right? Because 3 plus 5 is 8. It's greater than 7. So based on that, it gives us a start. Does 7.1 work? 7.1 works. So what about 8? Does 8 work? 8 doesn't work. What about 7.9? Yes. So we found that, and we found that number is 8. So the range would be between 2 and 8. So all the sides have to be in between those two numbers. So an easy way to do it, when I'm asking you what is the range of possibilities for that third side, 5 minus 3 gives you 2. 5 plus 3 gives you 8. Does that make sense? That gives you the range of possibilities for the third side. That's done. But look, also pay attention to the inequalities. They always point to the left. So while I do attendance, because the syllabus is going to get fired, let me do that real quick. You're doing good, Mr. Day. You're good. You're doing good. You're doing good, Mr. Day. So let me do attendance right quick. While you guys, I want you to answer this question. I want you to figure out what are the range of possibilities for that third side. Do that real quick. Real easy, real quick. Guys, those of you at home, maybe do the warm-up just in case I miss you for attendance. Might be a good idea. All right, Miss Sides, I'm going to come to you for this one. Oops, 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 oops. Hold on one second. Let me just do this. All right, Miss Sides, what'd you get for this? What are your range of possibilities for this triangle when you have 12 and 15? What'd you get?
I got 3 and 17, but like how you were saying the decimals before and after them.
Wait, say the last part again. I'm sorry, I heard the 3. I didn't hear the rest, sorry.
3 and 17.
Okay.
Like the decimals before and after them. I don't know.
You did it right. I think the only thing though, I know what you just forgot to carry over. Well, you don't have to carry over the one. I just think you misadded, but I think you did it right. I think you meant to say 27. So if you do 12 plus 15, that gives you 26. What the? That's the wrong bill. But did you guys get 3 and 27? Pretty easy, right? Just add and subtract. I know that's what you meant, Miss Sites. Okie dokie. So now I want you guys to click on this link. Can you?
Teachers and students, please excuse that bell. Please adhere to the schedule for Tuesday, Thursday. Thank you.
Click on the, I want you to see the, I want you to click on both of those like that. Click on those two boxes. You need to see those. This is called the hinge theorem, and basically all this wants you to do is to see if you have a triangle where two sides are the same, 6 and 8, but their angles are different. What conjecture can you make about the third side? Okay, so if you have one angle that's smaller than the other, what do you notice, as you change the angle? You cannot change the 6 and the 8, but as you change the angles, what do you notice about their angles? If one angle is less than the other, what do you guys notice about their measurement is kind of what it's asking. So if I look at the smaller angle, given that the two sides that include that angle are given the same, 6 and 8, the angle with the smallest, or the triangle with the smallest angle, is going to have the smaller side. Common sense, right? Right. But if you make this angle larger, then now this side will be larger than this side over here. That's the hinge theorem. And you can probably do the converse of that, that if the third side is larger than the other side, given that the two other sides are the same, then that angle also has to be larger, right? So if we go back to the, that's all that is. If you go back to the pair deck, just states that if you have a triangle where two sides are congruent to another triangle, but their angles are different, the third side will be larger to the triangle that has the larger angle, right? And then vice versa, you can do the converse theorem like that, but that's how basically the hinge theorem works. So take a second to answer this question. I'll read that. All right. Which statement is true? And basically what the hinge theorem is getting you to see is that, what did you guys select? Which one was the true statement? I think I heard somebody say it. That or I'm hearing things. Would you guys agree that, well, let me ask you this. Is SQ larger or smaller than YU? I think I heard both. So let's look at the angles right here. If I look at angle A, what's the measurement of angle A? 90. And then the measurement of angle O is 70. The triangle with the larger angle will have the larger side. So therefore, SK will be larger than YU because of the angle. Does that make sense? Everything else in those two triangles are the same. The two sides are the same, but the third side will be different on that. But that's how the hinge theorem works on that one. So if I'm looking at this robotic arm, now these are drawn to scale. I mean, you know, we wouldn't do that on the test. You're going to have to use the theorems correctly in order to answer those. But I think it's pretty obvious that the one on the left, the claw or whatever you call that, is further away from the base because of the angle, right? And I'm not going based on the picture, I'm going based on the measurement. Whereas on the right, it would be closer to the base because the angle is 40 degrees. And that's basically what the hinge theorem is trying to get you to see on that and how to use that. As you kind of go through that. This one's the same. The one I do want to get to is this. So when you look at this problem right here, how would you go about and how would you solve it? So you look at these two triangles, you have to use the hinge theorem. I know that, well, let me ask you this. Which angle is greater, D or G? They're not the same. D would be greater, right? Yeah, good job. So D would be greater because look at the 12 and then look at the 11. So if I go from outside and I go to this angle, 12 and 58 go together, 11 is less than 12, so therefore this angle has to be smaller. Does that make sense? Okay. So the smaller side goes with the smaller angle, which means that 3x minus 2 must be less than 58. But the angle has to be greater than 0 because we can't have a negative angle. So you'd have to solve both of these equations in order to find the range of possible, like what would be the measurement of angle G? Well, we don't know, it's a range. So you would do the algebra, you would solve this one like this, right? So you get x is greater than 20, but greater than 2/3. Oh, this should be less, this is wrong right here. This should be less than right here, right there. X is less than 20, but it's greater than 2/3. So this would be the range of possibilities for X. You'd have to solve both equations for that one on there. The smaller number will always go on the left, the larger number goes on the right, and you'll always use the less than symbol for both. This is the correct way to do a range, okay? So I want you guys to solve this one, whether you do it on a piece of paper, if you do it on the pair deck, whichever you prefer. Remember, and let me go back to the last slide. So you have one equation right here like this, and then one of them has to be greater than 0, okay? So try this one. So as you're working this out, just a quick question for you guys. The 2x minus 4, would that be less than 86 or greater than 86? Should be less than, yeah, good job. So I hate to disappoint you and show you how it's worked out, but this is how you should, hopefully this is what you were thinking. Less than 86, and then you always want to do greater than 0 because the angle cannot be negative. So we just want to do that range from less than 86 to greater. I'm pretty sure you have one of these on your test. So trying to give you guys a heads up, problems that you need to study, so on and so on. Anyhow, guys, the rest of the period, I do like this last problem. It's really good, but I hardly ever give you time in class to ask questions or if you have any questions about your grade. So I'll leave the last 19 minutes for you guys, if whether you're at home or in person, if you have any questions about your grade or anything like that. I am going to stop and look at quiz 5 to check those scores. Just, I know some of you mentioned that it, didn't look good or didn't look right. But go ahead and use this time to just work on your work. 5-1, 5-2, there's a bunch of homeworks. So all the unit 5, remember, I'm not marking late, so don't feel, because I did post 3 on Tuesday, don't feel like I'm not going to penalize you for being late for this topic. Just get everything turned in by Tuesday. Okay, so work on something from Delta Savas, and then I'm going to be looking at the topic 5 stuff. Somebody's asking how many homeworks I'm going to put in. I think it's quite a bit. I think there's 5, 1, 2, 3, 4, 5, 7, 8. So whatever that is. So like 6 or so. So those are the ones I'm gonna put in. So just those are the remaining homeworks. Nothing you can do right now, just get out of the way. You want free extra credit. That, what is it? The hoodie thing is open. Doesn't take long at all. So what I'm doing with that is, let me start recording.